So here we are asked to graph this function, and if you notice, it is a quadratic equation because we have an x squared whose a is not equal to 0. And we're also to find the solutions, find the roots. So that's the one change from 9.1 to 9.2 is we want to graph it. So we're going to go through all those same steps, but we're also going to find out what are the solutions, what are the roots. Okay, so first we're going to write the equation in standard form. Right? This is not in standard form. So how can we put it in standard form? Well, is the x squared, we look at the example here, x squared is to the left of the equal sign. The x, all the terms are to the left of the equal sign. And we have our 0 on the right side. Right? And then once that's the case, then we place the term with the highest degree to the left, then the term with the next highest degree to the right of that, and then the constant to the right of that, right? So if we look at this equation, you can see we need to move the 6 to the other side of the equation, and it also needs to be right next to the equal sign, right? Because our 6 is going to be our constant c. All right, so let's go ahead and do that. We're going to subtract 6 from both sides of the equal sign, and we're going to get x squared minus x minus 6 is equal to 0. All right, so it's in standard form. Now we identify our a, b, and c. Our a is the coefficient in front of the x squared, that's a positive 1. Our b is the coefficient in front of the x, that's negative 1. And our c is the constant, which is negative 6. All right. Next up is to find the x-coordinate of the vertex, or the equation of the axis of symmetry. This is two names of the same formula here, right? And so let's plug in our negative 1. So it's negative 1, which is b, over 2 times a, over 2 times 1. So that's going to be equal to 1 over 2. So 1/2. All right. So our vertex is going to be 1 over 2, or 1/2. Let me go ahead and check the graph. Give me 1 second here. Okay. So although the vertex is a fraction, I'm still going to be using whole numbers to the left and to the right of the vertex. Okay. So since we're at 1/2, I'm going to go to the left to 0. And then I'm going to go to the left of that to negative 1. I'm going to go to the left of that is negative 2. And then I'm going to go to the right of 1/2 on the x-axis. And I'm going to go to positive 1, 2, and 3. All right, so here we go. We have a symmetric table of values, right? 0 is 1/2 away from 1/2, and so is 1. And then negative 1 is 1 away from 0, and 2 is 1 away from 1, and so on, right? So now we can go ahead and fill in this chart, and remember, all we need to do is fill in this top portion of the chart, and then we can fill in the same values down below. And so, you know what? Actually, it's easier for me to work with positive values of x. So I'm going to fill in this bottom half of the chart and then use these values for the top half. Okay, so let's go ahead and start with the vertex is 1/2, and our y is equal to x squared minus x minus 6. Okay, so if it's 1/2, then it's going to be 1/2 squared, which is 1/2 times 1/2 minus 1/2 minus 6. So 1/2 minus 1/2, oh my goodness, what is that going to be? That's going to be 1 over 4, because when you multiply fractions, you just multiply straight across, right? 1 times 1 is 1, 2 times 2 is 4, so we get 1 over 4, minus 1/2 minus 6. So now we need to add these two fractions together, which means their denominators need to be the same. And so how do we get the 2 to be a 4? Well, we multiply the numerator and the denominator by 2, right? So I'm going to get 1 over 4 minus 1/2, but I need to convert that to have a denominator of a 4. So I'm going to multiply it by 2 over 2, right, which is 1. And so you can multiply any number by 1 and it will stay the same, which is why we can do this. And so then we minus 6, right? So it's equal to 1 over 4 minus 2 over 4 minus 6. All right, so from here, this is quite a beast of a little problem. We have negative 1/4 minus 6. Minus 6. Right? And then what is that going to equal to? Well, both the signs are the same, so we're going to add and keep the sign. It's going to be 6 and 1, or negative 6 and 1/4. All right, so over here it's negative 6 and 1/4. Sorry, I had to put you through all of that. And so now we're dealing with regular numbers, right? So x is 1, and so if I'm substituting in, it's 1 squared minus 1 minus 6, and so that's going to be equal 1 minus 1 is 0, minus 6 is negative 6. 2 is going to be 2 squared minus 2 minus 6. So that's equal to 4 minus 2 minus 6. So then that's equal to negative 8 plus 4. So 4 minus 8 is going to be negative 8, negative 4. 4 minus 8, negative 4, that's right. And then we have 3, so it's going to be 3 squared minus 3 minus 6. So that's going to be 9 minus 3 minus 6. And so this is 9 minus 9, right? So it's 0. Alright, and so now that I've filled out these numbers in my symmetrical table of values, I can use the same numbers up here. Negative 6, negative 4, and 0. And of course, it's always good to double check your work, right? So let's go ahead and double check with negative 2. Well, negative 2 squared is positive 4. Negative 2 negative is positive 2. So we have 4 plus 2 is 6. Minus 6 is 0, right? So our little trick here works. And then let's go ahead and graph it. So it's negative 2. Okay, so here it says step 5 is to find the x-intercepts from the table, right? And so what are the x-intercepts? Well, if we're looking here, the x-intercepts of this graph are where the graph crosses the x-axis, namely negative 4 and 0. And so how do you find that? You find that by finding x when y is equal to 0. Right? We know that the center of the graph is 0 on the y-axis. So what is x when y is equal to 0? So we're looking at our chart here, and our y is equal to 0 when x is negative 2, and our y is equal to 0 when our x is positive 3, right? And so right here it's asking us find. Oh, no, it's not. This is a different problem, actually. Oh, no, it is. Okay. Here, find the x-intercepts from the table. Okay. Well, we go ahead and look at the table, and we say, when is y 0? It's here. It's negative 2. When is y 0? Positive 3. So our x-intercepts are negative 2 and positive 3. Are negative 2 and positive 3. Okay, and so now we're going to graph, and of course we can also write this as a ordered pair, right? And so I'm going to put a comma here, and I'm going to say negative 2 comma 0 or 3 comma 0. It could be our x-intercepts. And so we'll go ahead and graph it, and I guess I'll start with this point here, negative 2 0. So we go negative 2 0. Our next point is negative 1, negative 4, negative 1, negative 4. And vertex is going to be at 0, comma negative 6. Oh, actually, that's not our vertex. Our vertex is at negative 1/2 and 6, well, negative 6 1/4. So where 1/2 is here, negative 6 1/4 is right there. All right. Now from here, I don't even need to look at the chart because we know that the right side is symmetric. So my next point is going to be there, and there, and there. Right. So let's go ahead and connect all of our dots. Draw our parabola, like so. And what is our solution? Well, they are the x-intercepts from the table, these 2 points. We could check graphically. What is our solutions? It's where the graph crosses the x-axis. And where does it cross the x-axis? At this point and at that point. What is this point? It is negative 2 comma 0, our first x-intercept. What's the second point? It is 3 comma 0, our second x-intercept. Alright, so we verified our answers graphically. Now we want to verify our answers algebraically. And we do that by taking our equation, which is y is equal to x squared minus x minus 6. Yes, that's right. And we are going to use x values of -2 and 3, right? -2 and 3. And if we substitute -2 into our equation here, our y should equal to 0. All right, that's how we check algebraically. Yeah, because we want to find what is x when the graph's y is equal to 0. That's where it crosses the x-axis. So let's substitute -2. So it's y is equal to -2 squared minus -2 minus 6. So that's equal to +4. This becomes a +2 and minus 6. And yes, we can see that 6 plus -6 is equal to 0. Let's try +3. Y is equal to +3 squared minus 3 minus 6. So that equals 9 minus 3 minus 6. Okay. And so -3 and minus 6 is -9. So 9 minus 9 is 0. So we can verify algebraically that these indeed are the x-intercepts. Right? And we're done.